Welcome students, welcome to Unacademy JEE English, welcome to this beautiful channel, and today we will be doing a sprint on integration. It is a very important chapter for your IIT JEE preparation, and we will do a lot of interesting questions, standard formulas and standard manipulation and reverse definition of differentiation will also be used in this session. So just start with the session. This is me, Umesh, and I have 5+ years of teaching experience, and I have done my BTech from IIT Kurukshetra, and I have also qualified JEE exam students. So those of you who have not subscribed to the channel Unacademy JEE, just subscribe to it, because a lot of interesting and beautiful lectures are going to be there for your IIT JEE preparation. And do share this video with the tag #JEELive daily, so that it reaches to the maximum number of people and they can get benefit from it. Okay students, and this is a interface tinyurl.com/JEE mobile that we have created for you. Here you can avail all the lectures that we have delivered on the YouTube. We have done indexing of each lecture class wise and chapter wise. So if you click on the lecture link, lecture will start, and if you click on the link of PDF will get downloaded. But remember, these lectures are in Hindi, so if you have any query in the theory, you can first clear that doubt of theory from the lectures, and then we will start the sprint session. So students, UMESHLIVE is my referral code for Unacademy subscription, and you must know that there is a recent drop in the price of 2-year plan. Now you can avail the 2-year plan by paying the amount just 32,400. That will be this amount. If you use my referral code UMESHLIVE, this referral code will avail you a discount of 10%. Okay, so let's start with the sprint. This is our first question: integral x raised to power 5 upon square root of 1 plus x cube. So this is a fundamental question of substitution. As we can already see that if I let 1 plus x cube as t, the 3x square dx becomes dt. So this is a question of substitution method. I'm starting to solve it. Just apply the substitution. 1 plus x cube equal to t. So differentiate it, it will become 3x square dx. It becomes dt. That is okay with everyone. 3x square dx becomes dt. Now apply this substitution to get the integral. So x square dx becomes dt upon 3. Now integral will become like something like this. Integral of x raised to power 5 can be written as x cube and x square. X square dx will become dt upon 3, that will become root of t, and x cube can be written as x raised to power 5. I have manipulated it as x cube and x square. Now x cube can be written as t minus 1. X cube can be written as t minus 1. Till now it is okay. Now just separate it and to get the answer. 1 by 3 is outside the integral, so it has become integral of t minus 1 upon root t. So just separate it, it will become root t minus 1 by root t dt. So these become standard integrals. You can easily solve them. I am solving it for you. 1 by 3, this will become root of t will become t raised to the power 3 by 2, and 1 upon 3 by 2 will become 2 by 3. That is okay with everyone. Minus t raised to the power minus half, it will become 1 by 2. So 1 by 2 and 2 times of it. Since 1 by 2 will come in the division, it will become 2. That is okay with everyone. Plus c. So just take out the t common, 2 common, and root t will be common. 2 and root t will be common. So it will be 2 by 3 root of t. What will remain inside? What will remain inside? It will remain t minus 1. That is okay. T minus 1. I hope everything is clear with everyone. T minus 1 will remain. Yeah, just one sec. 1 plus x cube, 2 raised to the power 9. Yeah, t by 3 minus 1. Yes, that was the mistake. T by 3. I have taken the common. Just take the common out as only 2. So it will remain t by 3 minus 1. T by 3 minus. This 3 will not be here. It will be t by 3 minus 1 plus c. Now just put the value of t as 1 plus x cube. Root t will be this. Now put the value to get the answer. Let me check again. 1 by 3 is outside. So yeah, okay, 2 by 3 will be outside. No issue. That we have taken 2 root 3 common. No issue with that. So just put the value of root t as 1 plus x cube. You will get the answer as A for Agra. Basic question, very basic question. Very good. So let's start with the next question. Integral of secant square x cos of tan x dx. This is again a very standard question of substitution. Just apply the substitution tan x is equal to k or p or t as you wish. I am using the variable k. So if you use tan x equal to k and differentiate it, it will become secant square x dx as dk. Secant square x dx will become dk. Now apply the substitution, it will become cos of k into dk. Now integral of cos k is sin k. Now put the value of sin k. So the integral will become sin of tan x plus k. Answer will come out to be sin of tan x plus c, sorry, plus constant of integration c. So answer will come out to be B for Bombay. Very easy question, understanding, basic understanding that you have to use substitution method. Got my point? So next question. This is a wonderful question, students. So whenever I see e raised to the power x in an indefinite integration, I get reminded of one standard integration, which is e raised to the power x into fx plus f dash x. If this integration is solved, then it will come out to be e raised to the power x into fx plus c. This is a standard integral that all of you should learn. Okay, e raised to the power x is equal to fx plus f dash x. So this is the standard integral. Now I am rewriting the given integral in this format. If I get successful, then answer is very easy. So the given integral, it can be written as e raised to the power x. Till now everything is okay. Now x minus 1, what I did, I added 1 and subtracted 1. So it will become like this, x plus 1 upon x plus 1 whole cube minus 2 times of x plus 1 whole cube integral dx. That is okay with everyone. What I did, plus minus 1, nothing else. Now this will get cancelled, and the integral will become e raised to the power x into 1 upon x plus 1 whole square plus minus 2 upon x plus 1 whole cube. This will become the expression. Now if you let this function as fx, this is written its derivative f dash x. Got my point? So this integral is solved and its answer will be, if this is fx, then this is written as f dash x. Very easy. So this integral will be equal to e raised to the power x into fx. Into fx will come out to be 1 upon x plus 1 whole square plus c. So answer will be e raised to the power x divided by x plus 1 whole square plus c. Basic question of indefinite integration. You must know this integration, that e raised to the power x into fx plus f dash x dx. This will come out to be e raised to the power x fx plus c. Got my point? So let's try the next question. This is also a wonderful question, very good question. Somebody wants to, some people wants to solve it by partial differentiation or partial fraction. They want to talk about big things. Just apply the simple mathematics, basic manipulation. Answer will come out like this. Now what I did, that since it is x minus 1, x minus 2, so I created these type of factors in the numerator by writing it as x square minus 1 plus 2. Plus 1, minus 1 and minus 1, I kept it with x square and plus 2 aside. So I am writing it, what I did, you just focus on it. It will become x square minus 1 plus 2, I can write x square plus 1 like this only, and this is like it, x minus 1 into x minus 2 and whole multiplied by dx. This can be written like it. Now separate these two things. If you separate it, it will become like it, x square minus 1 upon x minus 1 into x minus 2, x minus 1 into x minus 2 dx, okay, dx, plus what will it become, plus 2 upon x minus 1 into x minus 2. That is okay with everyone. So plus it will become twice of x minus 1 into x minus 2 dx. This is the simple manipulation that I did to solve this question. Now what will I do? Now this, this can be factorized as x minus 1 x plus 1, x minus 1 x minus 1 gets cancelled. So after that, what will be the integral? I am writing it. After that, integral will become x plus 1 upon x minus 2 into dx, plus what I did, 2 can be taken out of integration since it is constant. So 2 outside, and it can be written as 2 integral of dx upon x minus 1 into x minus 2. Now you just need to have a better, basic understanding. The difference of these two factors is 1, so 1 can be created very easily, and I can write it again as x minus 2 plus 3. Answer has come out. So write this factor as x minus 2 plus 3 and separate them. So x minus 2 upon x minus 2 plus 3 upon x minus 2. Integral of this, integral of this. Got my point? Plus 2 times of, here difference is 1 in numerator, difference is 1 na? So that 1 can be written as x minus 1 minus x minus 2 divide by x minus 1 x minus 2 and dx. That is okay with everyone. Now x minus 2 gets cancelled. Now integration of 1 will come out to be x. That is okay with everyone. Plus 3 outside the integral, and 1 upon x minus 2 integral, it will come out to be 3 times of integral of n minus 2. Somebody wants to keep mod, I don't have any problem with it. You can easily write it as 3 times of ln of mod of x minus 2. Now this expression, this needs to be solved further. If you again separate it, x minus 1 get cancelled, it can be written as integral of x minus 2. It can be written as integral of x minus 2. Got my point? That is okay with everyone, na? That if you separate them, it will be, x minus 1 cancel, it will be x minus 2 minus, if you again cancel them, it will be 1 upon x minus 1. And dx is written here, we want to integrate it. Now just integrate this one very easily. It can be separated dx, and 2 is multiplied by whole. So I am writing it again as, the answer will come out to be x plus 3 times of ln x minus 2 can be written as ln x minus 2 whole to power 3 plus 2 times of, this can be written as ln of x minus 2, minus 2 times of ln of x minus 1, and the final constant of integration can be taken as c. Now very easily, this will come in the power, this will come in the power, it is negative, so number will become in the division. So final answer will be x plus ln of x minus 2 whole raised to the power 5 divided by x minus 1 whole raised to the power square plus c. This will be your final answer. Got my point? This is the final answer. So the answer will come out to be B for Bombay. I hope everybody must have got the point that I want to convey. Very good question. This can be done by partial fraction also, but we generally avoid that because that does not give you anything to learn. You need to understand these type of manipulation because they will help you learn, help you solve the questions in further chapters also. Got my point? So next question. Very easy question, e raised to power x upon e raised to power 2x plus 5, this is integral dx. Now what I did, very simple question, e raised to power x can be easily taken as t. Now just differentiate it. So e raised to power x dx can be written as dt. There is no problem with that. Now apply this substitution. If you apply this substitution, the integral will become something like this, dt upon t square plus 5t plus 6. Now this can be factorized as t plus 2 t plus 3. So this can be written as integral of dt upon t plus 2 into t plus 3. This is the basic factorization, and difference of these two factors is 1. So 1 can be created in these two factors in terms of these two factors like this, t plus 3 minus t plus 2 divided by t plus 2 into t plus 3. Very easy question. And dt. Now separate it, answer has come. Once you separate it, t plus 3 gets cancelled. So it will become integral of dt upon t plus 2. minus it will become integral of dt upon t plus 3. So this will be something like this, integral of t plus 2 upon t plus 3. Now what I have assumed t is e raised to the power x, so answer has come out to be Bombay. Ln of e ki power x plus, ln of e ki power x plus 2 upon e ki power x plus 3 plus c. Modulus, if you can easily put, there is no issue with that. So answer was what? B for Bombay. Very easy question. Standard question on substitution of elements. Substitution in the integration. Yeah, this is basic question. Somebody wants to say that this is a question of definite integration. You can say that, but basic idea of integration is used in this question. So we have been given this equation as 0 to x f of t equal to x plus this integral. You need to find the f of 1. So what I did, initially I want to find out the fx. Once I find fx, then I can easily find out f of 1. So differentiate this equation from both sides. If I differentiate it using Leibniz rule, this left hand side will become f of x, and here u plus v, so derivative of u becomes 1, derivative of x is 1, and derivative of this factor by Leibniz rule, if you write, it will come 1 f of 1 and derivative of 1. The derivative of 1 is 0, so that will not contribute to the factor 0 minus, it will come out to be x into f of x, and derivative of x is 1. You got my point now, that this is the equation by after differentiating this integral, and I am differentiating it using Leibniz rule. Got my point? Now take this to the left hand side, f of x into 1 plus x is equal to 1. So f of x comes out to be 1 upon 1 plus x. Now what we need to find out? F of 1, just put x is equal to 1. So f of 1 will come out to be half. So answer will be A for Agra. Got my point? So f of x will be equal to 1 upon 2. Very simple question, very easy question. Next question. Value of integral x square dx upon x square plus a square into x square plus b square. Again, same question, same idea of question. Somebody wants to solve it, using the method of partial fraction. They can do it, no problem with that. But this can be done by basic manipulation. What I did, add a square, subtract a square. You can also add b square and subtract b square, that is also fine. But I did it for a square because that is the first factor that I saw. So add a square and subtract a square. The integral will become something like this. Just stay with me, it will be a bit lengthy, but very easy manipulations are there. Upon x square plus a square into x square plus b square. I hope till now everybody have understood what I did with this question. Add a square, subtract a square. Now separate. If you separate them, x square plus a square plus a square will get cancelled. Okay. So the integral will look like this. It will be dx upon x square plus b square minus, and take a square outside of integral, it will become something like this, dx upon x square plus a square into x square plus b square. I hope everybody must have got what I did, just separate them, it get cancelled. Now this is the standard integral, this is the standard integral, you can easily write it as tan inverse of x by b, but you must remember 1 by b will also come outside, because in case of tan inverse dx upon x square plus a square, if this is the standard integral that you have learned, that it will come out to be tan inverse of x upon a, and outside it will be 1 upon a. Now let's talk about this second integral. A square is outside the integral. Now here difference of these two factors is constant, because x square cancel, and since I am looking at the options, in the option b square minus a square is available. So I am creating that factor by subtracting this equation from this. So if I multiply and divide by b square minus a square, the division b square minus a square can be easily written outside, because that is constant, and that one which is in the numerator, it can be written as the difference of the two factors which are in the denominator, x square plus b square minus x square plus a square divide by x square plus a square into x square plus b square. I hope everybody must have got what I did, that first I observed that the difference of these two factors is constant, it is independent of x. Then I look at the option, the options are using the factors b square minus a square. So that's why I am introducing that factors by subtracting this equation from this. X square cancel, b square minus a square will come. Now if I multiply divide by b square minus a square, division the factor that is coming in the division, it can be easily taken out of integration. Now this b square minus a square can be written in the as the difference of these two factors. Now what you should do, sir, just separate these two, if you separate them, x square plus b square will get cancelled, and in the second factor x square plus a square gets cancelled. So I am writing it, the answer will be, the final integral will be 1 upon b tan inverse of x upon b. Till now no issue, I have written it the same, and here it is written minus a square upon b square minus a square. Now here what will come, you should easily understand, here comes x square plus b square, x square plus b square gets cancelled. So it will be integral of dx upon x square plus a square, minus second factor will be similarly x square plus a square gets cancelled, it will be dx upon x square plus b square. I hope there is no doubt in that, everybody is cleared on that. This one is 1 upon b tan inverse of x upon b. Now just solve these integrals, you will get the answer. This is written as minus a square upon b square minus a square, and this integral, what will this integral come out? This integral will be tan inverse of x upon a into 1 upon a. I think everybody must have got it. And what this will come out, this will be minus tan inverse of x upon b into 1 upon b. I think everything is clear. This is minus, yeah, everything is perfectly fine, no issue with that. Now just multiply this factor, it will come out to be a to a cancel, it will come out to be, and this will becomes plus, and I am writing the terms of tan inverse of x by b in one side and tan inverse of x by in the other side. You just look at that what I am doing. So the terms will become like it, tan inverse of x by b, this is the inverse that I am concerned about, and coefficient of this inverse will come out to be, it will be 1 by b, and from here minus minus plus, and it will come out to be a square upon b square minus a square, this is written outside, and from here it will come out 1 by b. So 1 by b, this is the coefficient of tan inverse of x by b. Got everyone? And then minus I am writing tan inverse of x by a, that is okay, and coefficient of this inverse will be a to a cancel, it will be a upon b square minus a square. I think everybody have understood what I did. Till here we solved the integration has solved, but now we want to write it in the format that question has asked us. Okay, sorry, for that what I did, tan inverse of x by b, the coefficient of this inverse I am calculating. So tan inverse of x by b kept aside, its coefficient 1 by b from here, and from here it will come out to be minus minus plus a square upon b into b square minus a square. So a square upon b into b square minus a square. That is okay with everyone. Now just take the LCM, you will get the answer. I am calculating it, don't worry. So just try to start solving it. This will be tan inverse of x by b. I hope everybody has got the idea. Now from here LCM will come out to be b square minus a square into b. So LCM will come out to be b square minus a square into b. Okay, so what will here becomes b LCM, so it will become b square minus a square. Here it will come out to be a square. I hope everybody must have got what I did with the LCM. And here what is written, sorry, here what is written, it will be minus of a upon b square b square minus a square into में tan inverse b square minus a square tan inverse of x upon a. A bit calculative question, but a very easy question, and you must know this type of manipulation. And you know, a square cancel, b gets cancelled. So the final equation will look like this: b upon b square minus a square into tan inverse of x upon b. That is okay with everyone? Minus a upon b square minus a square into tan inverse of x upon a. So just take 1 upon b square minus a square common. So 1 upon b square minus a square common, and answer will come out to be this one, a, b tan inverse of x by b minus a tan inverse of x by a. So this will be the answer. Got my point? Very lengthy question, but you must understand all this manipulation. Okay, what I did. So this was the final answer. Very good question. Now let's try the next question. If a and abc belongs to real number, satisfy this equation, then this given biquadratic has the roots in which situation? Okay. So this is a basically this is question of application of derivative and integration. We will use the concept of both of these chapters. So what I did, just rewrite this equation. The given linear equation is 3a plus 5b plus 15c equal to 0. You just listen to me, it will get very amazingly beautiful. Divide this equation by 15. So this will come out to be a by 5 plus b by 3 plus c equal to 0. This is the equation that I will use in the further in this question. Now this a by 5 b by 3 c, this type of expression can be easily created by integrating this fx. So I am assuming this function as fx. I have been given fx as a raised to the ax power 4 plus bx square plus c. I hope everybody is comfortable with what I have done. Now integrate this fx. Integrate this fx with respect to dx, and let's call that function as h of x. Let's call that function as h of x. I think everybody is clear on that things. So h of x can be is h of x will come out to be a raised to the pi a by 5 x ki power 5 plus b by 3 x cube plus cx plus d. So this will be the expression of hx. No problem with that. Now if I look at this equation and now I look at hx, I can easily find out some things. What will be the value of h of 1, if I want to, because now look at the options here, it is using 1 and minus 1. So I am rewriting hx. H of x is equal to a by 5 x ki power 5 plus b by 3 x ki power 3 plus c of x plus d. Now you can easily find out some standard results. First, what you need to find out, that h of 1 will come out to be what? A by 5 plus b by 3 plus c plus d. Now since 0, this is 0 na, a by 5 plus b by 3 plus c, this is 0, so it will come out to be d. And again h of 0 will be 0 0 d, and one interesting result more, which is h of minus 1. If you calculate h of minus 1, it will come out to be minus of a by 5 plus b by 3 plus c and plus separately d. Got my point? And this is again 0, so 0 into minus is 0. So h of minus 1 will come out to be d also. So this is the result that will solve this question. Now we have the result that h of minus 1 equal to h of 0 is equal to h of 1. So this is the result that we have come out of this manipulation. Now since hx is a polynomial function, it is continuous and differentiable in R, and I have concluded that h of minus 1 is equal to h of 0. Now apply Rolle's theorem. If you apply Rolle's theorem on the interval minus 1 to 0, you can easily comment that h dash of x will be equal to 0 for at least once in this interval, because h of 0 is equal to h of minus 1 and h dash x will come out to be fx. Therefore, fx will have a root from minus 1 to 0. Now again apply Rolle's theorem on the interval 0 to 1. From that also we can calculate, conclude that h dash of x will be 0 from 0 to 1. So h dash x is fx. Therefore, f of x will have at least 2 root in minus 1 to 1, because h of x has 1 root in minus 1 to 0 and 1 root in 0 to 1. Therefore, from minus 1 to 1, how many roots will have fx? It will have at least 2 roots. It can be more than 2, but for 2 we are sure. So fx will have at least 2 roots in the interval minus 1 to 1. So answer will come out to be C for Calcutta. I hope you can easily write that Rolle's on 0 to 1, it will give us the conclusion that h dash of x is equal to 0. I hope everybody must have got the idea. Yes or no? Very good students, very good. It was a very good question. Now let's try the next question. Variable x and y related by this 0 to y dt upon this. Actually this is equal to x. There is a x is equal to this thing. Now value of d square y upon dx square is equal to, we need to find out this. Let's try, it's a very simple question. X is given to us as 0 to y dt upon 1 plus t square square root. Now just differentiate it with respect to y and apply Leibniz rule. Dx upon dy will come out to be 1 upon 1 plus y square square root, and derivative of y with respect to y is 1. Now get reciprocate it. So if you reciprocate it, dy upon dx can be easily written as 1 plus y square square root. Now what you need to find out? You need to find out d square y by dx square, d square y by dx square. So further differentiate it. So d square y by dx square means we are differentiating it with respect to x again. Okay, that can be written as first derivative of root, it will come out to be 1 upon 2 1 plus y square square root. Then the argument, the derivative argument will be 2y and into y dash. I hope everybody is okay with that. Now 2 to 2 cancel, so y double dash, this can be written as y double dash. It has come out to be equal to how much? Y into y dash upon 1 plus y square whole square root. Now this is y dash can be written as 1 plus y square, therefore y dash will cancel out 1 plus y square. So d square y by dx square will come out to be y. This is a very standard question and very easy one, but you should understand these things, that if you get dx upon dy, you can reciprocate that to find the dy upon dx. Got my point? Very good students. Next question. So 0 to t square x f of x dx equal to 2 upon 5 t to the power 5. You need to find out f of 4 by 5. Okay, so again differentiating this equation by applying the Leibniz rule. Got my point? Because this is a function of t, this is a function of t, so it can be easily differentiated. So I am differentiating it applying Leibniz rule. It will come out to be t square into f of t square, just putting t square in terms of x in place of x, and then derivative of t square will come out to be 2t minus 0 f of 0 and derivative of 0 will come out to be 0. I am applying Leibniz rule in full spirit, you must understand it. And derivative of the right hand side will come out to be 5 to 5 cancel, 2t raised to the power 4. Got my point? Now very easy question. This has been solved to 2t cube into f of t square equal to 2t raised to the power 4. 2 to 2 cancel and final conclusion will be f of t square equal to 2. So t. Got my point? Now what we need to find out? We need to find out as f of 4 by 25. So f of 4 by 25, it will easily come out to be 2 by 5, because if you put 2 by 5 in place of t, it will become f of 4 by 25. So that is very easy. So answer will come out to be A for Agra. Got my point? Very easy question, fundamental question. So let's try the next question. Very good question. Let f of x equal to 2 to x dt upon 1 plus t raised to power 4, and g is the inverse of x. You need to find out g dash of fx, sorry, g dash of 0. So as I have discussed in the previous sessions also, previous sprint, I told you one very important equation. If there is a function and its derivative are involved and you need to find out the derivative of either of one, then you should always go by this equation, g of fx equal to x. Got my point? If g and f are inverse of each other, the composition of their function will always be x. Now differentiate this equation. This will become g dash of fx into f dash of x equal to 1. No problem with that. Now what we need to find out? We need to find out g dash at 0. So g dash should be 0. So we need to find out the x where fx is 0. Okay. Now we have been given, now write this fx. We have been given f of x as is equal to 2 to x dt upon 1 plus t to the power 4 square root. Now from this integral I can easily comment that f of 2 will be 0, because if you put x equal to 2, the limit of integral will become same. Lower limit and upper limit both are equal, so integral will become 0. Therefore what I did, I will put the value of x as 2 in this equation, so that f of 2 becomes 0 and I can easily come to the expression that I need to find out. Before that I also want to write f dash x, because I will use it. So f dash x will come out to be, it will come out by the help of Leibniz rule, it will come out to be 1 upon 1 plus x raised to the power 4 square root. Got my point? Now applying these results, so g dash of f of put x equal to 0, g dash of 0 will come out to be 1 plus x to the power 4 square root, and you need to put x is equal to 2 here. Got my point? Therefore g dash of 0 will come out to be under root of 17. I hope everybody must have got the answer. Therefore answer will come out to be C for Calcutta. Got my point? So student, these were the questions that we discussed today. Wonderful questions were there. Some were very calculative like this one, and some were very much logical like this one. So you need to understand that sometimes in indefinite integration calculative question comes, so you must have some patience and practice of that type of question so that you can deal with them in the exams. Okay students, so these were the questions that we need to discuss about indefinite integration. So this is our Instagram handle at the Unacademy JEE official. You can follow this page to get the updates about IIT JEE and our classes. And if you have not installed Telegram app, install it and type in your browser tinyurl.com/JEE-live-chat and join this group. A lot of nearly 30,000 students have already joined this group. This is a very relevant group for you. You can avail all the information in PDF about our lectures from here very easily. Now let's talk about Unacademy subscription. As all of you know that Unacademy is the best platform in India to prepare for IIT JEE, and there are some features which make it the best. First feature is live classes and interaction with the educator. Obviously students, all of you know that live classes teaches you better as compared to offline class, because your focus and concentration is much more in case of live classes. And also if you missed any step, or your calculation, you missed any manipulation, you can easily rectify that problem by interacting with the educator via chat. This is a very amazing feature on the Unacademy platform. There is feature of live pools, because students there is a need of speed with accuracy for IIT JEE exam. You can easily acquire that skill and nurture that skill by just this feature, live pools and leaderboard. Okay, and we offer you test series of India level so that you can easily check that where do you stand in that competition. And there is a feature of live doubt classes. This is a very important feature. This is very relevant for IIT JEE aspirant also, because for IIT JEE aspirant doubt clearing is must. Whether it is of theory or numerical, your doubts must be cleared. Therefore we offer you this feature, live doubt clearing session, where all your doubts gets cleared. and this is how our platform looks like. 60 plus educators are already there on the platform. Once you subscribe to the platform, then there is no constraint. You can watch the video of any educator. There is no constraint on that. Okay student, this is how a plus class looks like. You can upload your doubt and get your doubt cleared, and you can learn infinite from this platform. Now let's talk about how to join the Unacademy. Very easy method bachcho, very easy method. You just install the app, make your profile, set your goals to IIT JEE, and click on the get subscription button. Once you click on it, this window will pop up, and here the plans have been written: 1 month, 3 months, 6 months, 1 year, 2 year. What I want to draw your attention towards is that there is a recent drop in 2-year plans cost. It has come down to 32,400. Now you can easily avail the 2-year plan by just paying the rupees 32,400. But for that cost, you need to use the referral code UMESHLIVE, because this is your discounted cost. And if you use the Umesh referral code UMESHLIVE, you will get a discount of 10%. Got my point? So students, this was our session, and those of you who have not subscribed to Unacademy JEE, do subscribe to the channel and click on the bell icon to get the notification, and do share this video with the tag #JEELive daily, so that it reaches to the maximum number of people. And link to the PDF for this lecture will be in the description box. And these are our YouTube channels: Unacademy NEET, Unacademy JEE, Unacademy Foundation. And let's crack it students, let's crack it. Thank you very much.